The next case study is on a quote-unquote simple compounding. Most people will come in thinking that compounding is very straightforward to get reproducible PK. All you do is take a white powder, suspend it in some water, and dose it. You'll see in this case that it's not always that easy, and you really still need to understand your molecule to get a high probability of success for your phase 1 formulations. Some of the issues of this compound: it had exceedingly low solubility and was very hydrophobic. As soon as we ran the contact angle, we knew there was going to be an issue with hydrophobicity. See the high value of the contact angle, we know this isn't going to wet well, and you're going to have issues making suspensions for your compounding. The API is known to have a bitter taste, so we had to taste mask it, and it also had a small impurity that gave it a pink color. They did use a double-blind study in their phase 1, so we needed to use amber vials, taste mask, double-blind, meaning that neither the patient nor the administrator should know whether it's placebo or API. For GLP tox, this client used a simple suspension in 1% methicel and tween. And what they noticed was PK data was all over the map. And so what we immediately wanted to understand is, was that due to formulation? We wanted to take formulation out of the equation so that any variability that you see in your PK data is due to the compound and the in vivo performance of the compound. How did Crystal Pharmatech understand the molecule here to resolve the issues? First off, we needed taste masking. As a high level, this entire resolution process took us about 2 weeks development time. The taste masking we chose was Orablend. And why did we choose Orablend? Because they were very forthcoming and easy to work with as a vendor. They gave us the composition of the Orablend so that we can do proper excipient compatibility studies. The next thing we notice is that the API really liked to stick to the spatula. So when we were making these mixtures, we had to start by making a paste, then adding in more Orablend, and before we removed the spatula, to perform some sonication to ensure that all the API was in the dose. Sonication and homogenation were, again, had to be developed, and we had to really hit a sweet spot. As you can see from the PLM images here, not enough sonication or homogenation would cause bubbles to form, and that's where the API would come together and lead to variability in your PK studies. We had to place each suspension in a refrigerator without stirring, and then when the bottle was given, it had to be rinsed with water to ensure all the API was given to the patient. With this procedure, we were able to have enough chemical and physical stability to be able to dose prep every 7 days. When compounding, you also have to take into account what they're going to have at the hospital or clinical site that they're doing the compounding. In this case, they didn't have a particle size analyzer. They did have a microscope, so we were able to set up some tests, PLM image tests, in case there were some issues with mixing at the site. So some final thoughts. What does Crystal Pharmatech do that other CDMOs do not do? We're always thinking of first time right, dipping development into research, understanding the molecule, clear understanding of the material, streamlined formulation that's tailored to your clinical strategy and company strategy, which is going to give you a very high probability of success. We've come up with this Gantt chart to show you some of the timelines and some of the key decision points for that formulation development. We suggest that you start early on in your development. This is not front loading. With small amounts of material, you can use industry benchmarking. Large pharmaceutical organizations have been developing compounds for many, many years, and they have many compounds in development. They've come up with flowcharts of developability that are very easy to fill out with small amounts of information to tell you how difficult your compound is going to be to develop and whether you're going to need an enabled formulation or a salt's going to be okay, or even the free base or free acid just in a milled situation. Small amounts of material, late lead op, early candidate selection, developability assessment that sets your form path, your API form path, and your formulation path. Then do a one and done form selection. Don't go in a sequential approach and don't go in a shotgun approach. Use the molecule, understand the molecule to get the right approach for the form selection. If you need to take a look at enabled, do it right away. Get an enabled versus a salt, maybe even against the free base. Get that definitive PK study where you're then going to make this form selection for your GLP batches, API and GMP batches, and your formulation development pathway. We also suggest PBPK modeling. It's come a significant way in understanding and predicting human PK. Most importantly, you can understand the absorption, the criticalness of absorption from a formulation standpoint. Mixing in the strengths of DMPK scientists on the project team, you can understand metabolism pathways and really get an idea of how formulation is going to impact your absorption and your exposures in vivo. After the form selection, this leads then to a very streamlined, tailored formulation approach because we understand the molecule so well. We understand the material so well. We minimize the amount of API that's needed. We use technology like the compaction simulator. We minimize the number of prototype formulations. We don't go with super placebo. We then have the minimal prototype, lock in your final formulation, deliver your CTM material. We feel this is the most efficient path, and we want you to talk to us about how we can help your molecule become a medicine. Thank you for your time.